I'm getting ready to start restoration on this mid-1980s vintage Harman Kardon system. It's a two-piece setup with HK825 preamp and HK870 power amp. Not sure what's wrong with it yet, but I do know that the speaker jacks are broken on the power amp and the screws are missing. The owner just wanted this restored, so I'm going to be digging into both parts and checking out whatever could be wrong with it and hopefully restore it to perfect working order. But I can tell already that it's going to be a pretty big project, because looking at the schematics, this thing is just packed full of capacitors, or at least the preamp is anyway. But this thing, despite the age, was in its original boxes, which that's kind of unusual for something this old. And that's actually what made the mark on the case here, is the styrofoam packing blocks. So it may have been in storage for quite some time. Here's a look inside the amplifier. This thing's got quite a bit of weight to it, and it's no surprise. It's rated at 100 watts per channel, and it appears to be a dual power supply design. I can't remember if it's got two separate transformers under this cover or not, but there are independent rectifier circuits and separate filter caps for each side. I think that's the first time I've seen a bridge rectifier with a built-on heatsink like that. Those aren't very common, at least in the stuff I've worked on. And these heatsinks also look really familiar. I think I've seen them in like the Pioneer, some Pioneer receivers from the same era, like the SX3700 or 3900, something along the lines that I worked on had these in there. And I'm wondering if they're made by some other company and just sold to audio manufacturers. But these are what's called a shaved fin heatsink, where they start with a solid plate of aluminum and they cut the fins out of this main plate and just bend them back into shape. And the advantage is they're a lot more efficient to getting rid of heat, because there's no mechanical bond between the two parts of the heatsink that can loosen over time. But anyway, enough about heatsinks. We have the driver circuit here on its own little stand-up card. Thought it'd make it a little bit easier to service. And very thankfully, there is also a bottom access plate on this to get to the bottom of the entire circuit board, so that's a nice thing to have. None of the fuses appear to be blown, but that doesn't mean there's not a problem. And in fact, I noticed even when I first brought this home that these speaker connectors were detached from the case and one of them's broken off. I think what I'm going to do is replace these with newer style binding posts, because these don't accept banana plugs. There's nothing metallic in the center of these, and I think it'd be nice to upgrade that to be more universal, even though the spacing is too far apart to work with dual banana plugs. At least it would work with the single pin style ones. And I'm going to hook this thing up and see what I get out of it before I go any further. I'm not sure what's going on with it. Well, this is interesting. I've got severe distortion on one channel and about 10 volts DC on the other channel. That's not cool at all. And it seems to kind of come and go. So this preamp or driver board here is in a socket, and moving that around, now I've got a clean output on that one channel, and the voltage is kind of going all over the place on the other channel here. So first thing I'm going to do is check these connectors that hook these two boards together. I think there's broken solder joints and possibly just the oxidized connectors themselves. Here's the underside of the amp chassis. It's got some good shielding down here. There's a cross brace between the power and signal compartments, and they've got aluminum covers over the output transistors. That's kind of neat. The thermal diodes are attached here, one on each side. And looking at the two rows of solder joints that go to the driver board, the ones on the far ends are definitely cracked, probably two on each connector. So those are going to have to be resoldered. I'm probably going to resolder all of these actually to make sure they're just in good shape, and check over the whole circuit board for any other dry solder joints. Here's another example of bad solder joints. I've got a it's hard to do this with the camera so close. There's a ring fracture here, And another really nasty one that I found, this first transistor here, that lead just picks right up off the solder, not even attached anymore. So I'm going to have to take all 4 of these covers off and check all these output transistors to make sure they're soldered good. Well, it's a good thing I decided to check all these transistors, because it turns out quite a few of them were cracked in that same way. I don't like how they had these mounted with the leads floating a considerable distance above the board, so I'm going to remove all the solder and push the leads down so they're touching and then resolder them, and it should make it quite a bit more dependable that way. And this glue here, I've seen on other receivers that have this type of adhesive where this stuff would actually get moisture in it and corrode the copper and stuff underneath. So I'm going to check and make sure that's not going on here. Now that the transistors are all resoldered, I've just got to find some new adhesive to replace this old crusty stuff with. It is actually eating into the copper a little bit, so that's going to have to be taken care of. That can become conductive and cause all sorts of weird problems. Lots more broken solder joints on this driver board. Check this one out. There's almost no solder on it at all. Luckily there's not too many caps on here, so that should be a fairly simple replacement. But I think first I'm going to fix the solder joints and give this thing a quick test run. See how it stands before I go any farther. Even after fixing the bad solder on the board, I've still got 9.5 volts of DC offset on the left channel, so I'm going to have to look into that circuit a little further. Well, after a minute or so, that DC offset problem went away on its own. Probably another bad connection in that driver board somewhere. The output transistors themselves all appear to be good, which I'm very happy, because I can't really get these anymore without some trouble. However, the left channel has distortion, and I hooked up the scope, and now I can see what's going on. There's some pretty nasty crossover distortion, and I suspected bias, and sure enough, after hooking up my meter to the test points for testing the idle current, I have no idle current on the left channel. So that explains why there's crossover distortion. These transistors aren't turned on enough. In fact, they're physically cooler than the ones on the other channel because they're not conducting enough. So I got to figure out what's going on in that driver circuit. It could be the potentiometer itself or one of those transistors in that circuit for the idle current. Well, after that adjustment made no effect, I looked at this board some more and discovered that the driver transistors were bad, and also the resistors on the emitters for those were open. I got the approval from the owner to do the restoration on this, so most of the parts are here now. I've just got to get everything sorted through and find my parts list and get to work. I ended up removing the driver board from the amplifier so that I could clean and inspect it easier, and after I had gotten done removing all the flux that was on the board, I saw that there was just a ton more bad solder joints that I didn't notice before, and ended up having to resolder probably 80% of the board and then do flux removal all over again. It took me probably an hour and a half. Had to do a really close inspection with this thing, and I think that it was a combination of problems. Either they soldered at too low of a temperature, or they just had really crappy solder, coupled with the fact that the holes for the component leads are kind of on the larger side, and the solder was having to fill a larger gap, and it just didn't hold up to vibration and temperature stress over time. So the main board had a few joints like that on it, but not nearly the problem that the driver board had. This thing was pretty severe, and there's no doubt in my mind that several broken solder joints is probably one of the main things that contributed to the failure of the driver transistors. I thought it was a little strange that despite the fact that this amplifier is all direct coupled, the input board is capacitor coupled, right where the signal comes into the amp, and they're using a pair of polarized electrolytics in series back to back to make a non-polarized cap, and since each of those caps is 220 microfarad, that would give 110 microfarads per channel for the decoupling cap. or signal coupling cap. And ideally you would at least want to use something like a film capacitor to couple the audio signal for something like this, but I couldn't find anything physically small enough that would fit on this board, so I ended up keeping the original setup, but I changed the old caps and put Nichicon KT series in their place. And, well, I'm just about done replacing capacitors in this. There's one little one left back in here, and I think there's a couple more underneath this metal cover, and it looks like I've got to remove the bridge rectifiers to get that out of the way. Other than that, it's moving along pretty good. Here's what it looks like underneath that cover. Got the 4 main filter caps, then there's one 47 microfarad 16 volt capacitor there in the center, and the other one in the back, which was already exposed. A couple of diodes and a couple of resistors way down there between those caps, and they've got that stupid brown glue all over them. Hopefully they're not damaged. I got to clean this up a little bit while I got the cover off, and I've already got those caps changed. I'm going to get this put back in. And during the final test, I got to make sure these main filter caps are still within tolerance, because I really don't want to replace these if they're still good. They're pretty doggone expensive. So, moving right along. I'm in the process of doing the rough adjustments on the DC offset and idle current for the left channel. To measure the idle current, you just look at each pair of transistors has a shared emitter resistor. There's 2 resistors in one package, so there's 3 pins. There's 2 here and 1 in the front, and you just measure across one side or the other to get the idle current for each given pair of transistors, and set it to 50 millivolts plus or minus 5 millivolts. Right now it's running at 56, just a touch high, but I'm waiting for it to stabilize. Temperature, you know, the temperature has to come up and stop wherever it needs to before I can do the final adjustment. And it's been running for a couple minutes, but everything looks okay so far. It's not wildly out of tolerance like it was when I started. In fact, the right channel, before I did anything to it, it was running at like almost 120 millivolts, I think. Just way too high. And with the new components, it's definitely a lot more stable. Another nice thing about the banana plugs in my test speakers there that I installed fairly recently is that I can unplug my speaker leads from there and then plug directly into this meter and use it to adjust the DC offset at the speaker outputs. Saves a lot of time on switching cables around. One of my favorite parts of working on audio stuff, testing it. Yeah, it's working perfect so far. Getting close to being done with this part of it. Just out of curiosity, if I lower the volume way down so that it's like quieter than talking level, I think the camera actually picks it up better. I guess I'll find out when I play the video back, but in past experience, this camera works better at very low volume. It's a pretty good amount of heat coming off these heat sinks, but they're about the same temperature, and I know they're doing their job, getting the heat away from the transistors. I've got it raised up a little bit off the bench because it doesn't have its feet to space it out for the air intake right now. Can't wait to get the cover back on this and move on to the preamp and then listen to this as a completed set. I'm in the process of replacing the old speaker terminal assembly. This plastic is very brittle and it's just crumbling more and more each time it gets used. And rather than drill any more holes in the back of the amp, I decided to use the existing mounting holes and just adapt them to work with regular binding posts. And all that took was a small metal plate that I drilled with the existing hole pattern and used the two old mounting holes that used to mount this. And then that allows me to put standard binding posts in here with a minimal change in appearance. Here's the new speaker terminals, all installed and ready to go. Since the back of the binding post didn't line up with the original slots in the filter board where it was soldered together, I used some solid copper wire to kind of extend the binding post out and over so that everything's still lined up, and I was able to solder it in place. I'm getting ready to start on this preamp now. I did a quick test on it and it does pretty much work, other than the usual really noisy controls, you know, making one channel or the other cut out because they all need to be cleaned really bad. The volume control is also a bit noisy, which kind of concerns me because that's a large sealed unit made by Alps, and I'm not looking forward to drilling holes in that to get deoxid in there, but something that's got to be done. Also got a bunch of these small switches on the front that appear to be somewhat sealed. These ones back here will be pretty easy because they're open on top. And I can't tell if these two silver things back here in the corner are relays or if they're switches that are linked underneath. I'll have to look at them once I get the bottom cover off. I think the worst part of this is just going to be how time consuming it's going to be replacing all these capacitors. I mean, there's just tons of caps in here. But on the good side, I've seen other ones of these preamps where that brown glue was really all over the place and had caused a lot of component damage in this power supply section. But this particular one, they seem to be a little more conservative with that glue, and it's only really around the larger filter caps there, so I'm really glad to see that. It could have been a lot worse. And I also see some evidence of possible spill damage on the board here. Luckily it didn't really corrode anything. There's just some residue or something had spilled on the board and dried at some point in time. And yeah, I don't think it's going to be too bad, but we'll find out when I start getting it apart here. I've got the faceplate removed to keep it out of harm's way while I'm working on the main part of the chassis, and also to clean behind it and such. It's not in too bad a shape. There's some dirt around the buttons and the volume control, but no major scratches or anything. On the back it's got those typical button holders that are, this time they're actually held in place by double-sided tape instead of glue. Got a foam shield that divides up the light between each of the LEDs so they don't bleed into each other. And this is actually a metal faceplate. When I first looked at this thing, I thought it was plastic with like a fake metal look to it. But the only part that's plastic are the end pieces. The rest of it's metal, so it's like a textured aluminum. Pretty neat. Got the main bottom panel removed now. You can see a lot of residue around the volume control. Looks like somebody probably tried to spray some cleaner in there at some point, but I'm not really sure what that is. Looks like most of the electronics can be accessed through this panel, but not everything. There's also some stuff over here, so I think I'm going to have to take this off. But I'm just going to start replacing all these caps and get done what I can before I've got to take it any farther apart. Well, I've got one side of the preamp recapped. There's quite a few caps over there. Power supply side's a little more tedious because I have to take a big cross brace off the frame. Actually, there's like a plate that goes from front to back and also holds the transformer. And then there's a smaller cross brace that goes through here And these two screws here have insulators on them, and there's a couple different types of screws elsewhere, so you have to take note of where each one goes. And also underneath this switchboard there's a bunch of caps, so it's just a little bit more difficult to get to everything, but shouldn't be any harder than this side was once everything is accessible. Well, about 6 hours later, I'm just about done with the recap job, and part of that time has gone into inspecting everything, and I'm still finding broken solder joints all over this, just like I was in the power amp. Some really bad looking ones on some small transistors in the power supply section that I've got to take care of. I also ran out of flux remover, which is why the board is still a mess. And what else did I run into on this? All the caps in the signal section really weren't bad. In fact, a lot of them tested absolutely perfect. However, in the power supply, there was lots of bad parts. There was quite a few caps that were leaking and corroding, and they tested open. And I've got quite a few things with broken solder joints and some more corrosion damage, probably from the leaking caps. They were like putting off some sort of vapor. They smelled like fish when I heated them up with a soldering iron, and I could hear them sizzle. And I think that's what's been corroding some of these small components down here. So I'm probably going to have to replace a few of these resistors and a couple of these Zener diodes that are buried down in here, because the leads are all green. I didn't notice it until I was replacing those small caps, but almost all these little ones here were bad, and then this one back here, and a couple of the ones up here weren't too healthy either. But over here on this side, almost all these caps that I tested after I took them out, they were all perfect, but I changed them anyway because they're pushing 30 years old, and I just don't want to leave the original ones in there. Just got to do the flux removal and also do some cleaning up on the component side, and then move on to cleaning the switches. But I'm going to give this thing a test run just to make sure everything's still in working order. Got everything set totally flat. Not using any EQ whatsoever. It still sounds pretty good. Turn the bass and treble up a bit. Still surprised at these speakers sometimes. They seem to sound good no matter what kind of equipment I've got plugged into them and what kind of EQ curve I'm using. I don't know what it is about these speakers, but they're sweet. Boy, can you guys hear the difference in mono versus stereo? It's a pretty good sound stage, especially considering the amp that I'm using up there. Just little amplifier that come out of some old computer speakers. I just finished replacing a few components down here in the power supply section. That the leads were all corroded from the capacitors leaking, and it looks like there was 4 resistors and a 15-volt Zener diode. And I knew they looked kind of bad, but it confirmed my suspicion that they were affected by the caps. When I went to unsolder these, and as soon as they got warm from the desoldering gun, I could smell that same nasty kind of fish smell that the caps made when they got warm. So they were definitely corroded, and even though they tested within spec, I never trust a component that's got corrosion on the leads, because a lot of times it works its way up into the body of the component and causes all kinds of erratic behavior. So that's out of the way, and everything else looks good down here. I think this thing easily sets the record for the most broken solder joints I've ever seen in one piece of equipment. It's very hard for me to get this to work on camera because of the bright lights above the bench, but I've already resoldered some of these, but like these two right here are completely broken off the board, and also on these selector switches for the source selectors, the ones in the corners are fractured all the way around. And every time I look at this thinking I'm doing the last check, I end up finding more. Blows my mind how this thing ever even worked in the first place. Well, unfortunately I've hit a snag, at least with the phono input. This is the relay that selects between phono 1 and 2, and it's a latching relay, basically just a slide switch hooked up to a relay coil. It is a 4-pole double throw, although only half of it is used, and I could not get this thing to switch over between the phono inputs. It was always stuck on one of them. And I found out that see if I can get this out of here. Anyway, the front coil is shorted out, which blew the transistor that drives it. I took it out, it was right down there, Q21. And I don't know if I'm going to be able to find one of these relays, so I might have to bypass it to wire this permanently to be on phono 1 and just not use phono input number 2. Another option I have is to use a different kind of relay and adapt it to fit one way or the other, as long as it's got a 36 volt coil and at least double pull double throw. But I'm really not sure what I'm going to do at this point, because for one, I'm going to go over budget, and for two, I don't know where to get something like this. Well, another 2 or 3 weeks down the road and I've got a lot more progress on this. I had to retrofit a modern relay in to replace the burned up original, and it's a fraction of the size of the original one, so had to get creative with the mounting. I used a little breadboard that I had laying around and a standoff that I salvaged from a computer case many years ago. I threaded that on the back of the phonoground terminal since there was enough extra threads on there, and that gave me a perfect mounting position for that relay. And it works. It's a lot quieter than the factory relay. Here's what the factory relay sounds like. That's this one here that selects between moving coil or moving magnet phono cartridge. And the new one is way quieter. There's actually 3 relays in here altogether. This little one over here is the master mute relay, and then of course you got your phono selector back here that I just replaced, and like I said, the moving coil or moving magnet selector. Since the whole reason for that relay coil getting burned up was because of a leaky pre-driver transistor, I ended up just doing preventative maintenance and replacing all 10 of the transistors in this muting circuit. The small 2SC2603 is actually known for getting leaky, at least from what I've read online on more than one occasion. They were used in other audio equipment from the era, like guitar effects pedals and things like that. I replaced the 2SC2603 with KSC945C, and for the larger 2SD667s, I replaced those with KSC2690AYS. I figure a few transistors and a little more soldering is a lot easier than replacing another one of those proprietary relays. I'm testing the output power, and at 1 kilohertz I can get 30 volts per channel just under clipping. That calculates out to about 112 watts per channel RMS into 8 ohms. It's just a little bit over its official rating of 100 watts per channel. But I'm a little curious about the frequency response on this thing. Let me see if I can switch over to a square wave. I don't know how accurate it's going to be with this test bench setup though. Well, I can forget using the computer to generate a square wave for test purposes, because this is what it looks like coming directly out of the sound card on the computer. At first I thought it was the amp, but then I moved the scope right over to the sound card and it looked exactly the same, so the amp was just copying the signal perfectly like it should. But anyway, I'm not sure what the deal is with the sound card, because it's an M-Audio Delta 44, exactly the same thing I use on my big system in the other room. In fact, I tried swapping the breakout box and it does the exact same thing. So it's probably just a limitation of the digital to analog converters on these particular cards or something. Because I'm pretty sure I've used this program on other computers to generate square waves and it didn't look that bad. Not that you should be using a computer to generate test signals in the first place, but for me as an audio enthusiast, I'd prefer the signal to be a little cleaner than that, even with music. So I don't know. That's a thing to worry about another day, I guess. I gotta get this amp finished up. 100,000 stories have filled my head. Well, I've been running this thing all day long and haven't had any problems. Secretly waiting for my life to change. And with this transformation, something strange. Now my world is bigger than I know. I'm losing all control. I never thought. The room acoustics are quite a bit different on this end of the room. Now it's too bad with the way that the audio is limited on the camera that I can't really get a recording of what this sounds like in person, but I gotta work with what I got. This is probably the most complicated restoration I've done so far, with the one in second place being the Pioneer SX850. But this one definitely tried my patience on more than one occasion, but it turned out great. It's come a long way from what it was. I don't think I've ever had to fix so many problems on the same piece of equipment, but it turned out good in the end. This video was kind of all over the place because really this whole project was all over the place. I worked on it over several weeks' time, on and off, whenever I had time, and I had several snags, whether there was new problems that popped up or I had to stop and order more parts, and just life in general getting in the way. Otherwise, I mean, this should have been done a long time ago, so I'm glad to see that it's going to be out the door soon.